Swayam Prabha. Digital India. Educated India.
Today we will discuss corrosion protection related to change of environment and corrosion protection by coating. So, first let us see change of environment. For example, this means that for example, we can get rid of oxygen, we can get rid of moisture. So, there are many ways, and mainly the removal of corrosives, that is basically incorporated in the change of environment, or decreasing the activity of corrosive elements by adding some chemicals from outside. So, let us see what are the ways we can do. One is we can remove moisture removal, and for that we can add we can do dehumidification, and for that many a times we keep silica gel, solid silica gel. Silica gel we can put it, which can absorb moisture and prevent corrosion. Then we can also decrease the humidity. Humidity we can decrease by increasing the temperature by around 6 to 7 degree Celsius. Though with the increase in temperature, there generally the corrosion rate increases, but the increase in corrosion rate will be superseded by the decrease in corrosion rate due to the lowering of humidity due to this increase in temperature. So, this is another way. Then we can have oxygen removal. Oxygen removal, because in case of neutral or basic medium, we see that this is the major cathodic reaction, or even in the acidic media we have dissolved oxygen, then this reaction can occur, which is also cathodic reaction. If we can get rid of this oxygen, we cannot have these two cathodic reactions. So, we can reduce the corrosion rate of the metal object to a great extent, and for that how would we be able to do it? Either we can purge with nitrogen gas or argon gas, which are inert gas. Through the solution, if we purge that nitrogen or inert gas, we can get rid of oxygen to a great extent, or we can introduce evacuation if needed, or we can introduce scavenger. Scavenger, what it does, it actually reacts with oxygen, dissolve oxygen, and then get rid of oxygen in the solution. So, one such example of scavenger is for example, one such example is Na2, this example Na2SO3. If we add that in the solution, then it will react with dissolved oxygen and form Na2SO4, and this is one scavenger which is active. This is added where at low temperature. This is low temperature. This scavenger would be very good in removing the oxygen, or we can at high temperature we can add some hydrogen which is N2H4, which will also react with the dissolved oxygen and form nitrogen gas and water molecule. Now, this dissolved oxygen, this oxygen is basically the dissolved oxygen which will be scavenged out by, which will be taken out from the system by these two molecules, and in this case this is basically when the temperature is little high, that time you can use, one can use hydrazine which will take care of dissolved oxygen, and this nitrogen also would have the purging effect. So, this is the effect of scavenger. Now, then we can also have we can also remove acid from the solution. Acid removal can be one option. If we remove acid, then the corrosion rate can reduce. We can also take care of, we can also get rid of chlorine ion, since chlorine ion is a very active element, active ion which leads to pitting or crevice in a particular system, or it will also act negatively to the passivity. So, if we have chlorine ion, then passive layer formation will be delayed. So, if we remove this, we can also increase the corrosion resistance. Then 6, we can also get rid of solid particle removal. So, solid particle, if we remove it, is basically a sort of trap filter to the inlet section of the solution. So, if we remove solid particle, we can avoid the crevice related attack, since we have seen in the solid particle can lead to crevice corrosion on the bottom of water tank, or it can also lead to erosion corrosion if we have a relative movement of the solution with respect to the metal surface. Then we can also get rid of salt removal. Generally, most of the salts, they increase the conductivity. If we remove salt, the conductivity will decrease, or the resistance of the solid solution would increase, and hence the corrosion resistance would also increase. And finally, we can also add chemicals which are added in a very small amount, maybe of the range of ppm level, and which can increase the corrosion resistance of a particular metal by either taking care of the corrosive elements or corrosive species, or which can also form some passive layer on the surface and also enhance the corrosion resistance. Those chemicals are either organic or inorganic. Those are called, or vapor phase, or it can be in the form of vapor. Those are called inhibitors. So, if we change environment in this manner, we can increase the corrosion resistance. Now, coming to these inhibitors, let us discuss little more on these inhibitors. So, if we see inhibitor, let us discuss this part. So, as I have told that inhibitors are chemicals which are added, a very small amount is added in the solution, and of the it may be of the range of ppm level, and when it is added, that time it enhances the corrosion resistance, and there could be inorganic or organic substance. So, the main characteristics of inhibitors, the characteristics of inhibitors, let us see what are the characteristics. Characteristics, one is most of the situations, if we think of having inhibitor in the system, the choice of the inhibitor is done through trial and error method, to choose for the choice of inhibitors. Now, in a particular situation, then we can also and they can be organic or inorganic. But most of the cases they are generally organic in nature, and inhibitors, many of the cases inhibitors composition, exact compositions are not known, because many a times those are copywritten chemicals. Now, inhibitors definitely are costly as well as toxic, and the amount of they are specific. It means that for a particular system, for a particular metal, one inhibitor can work nicely, but that cannot work in other case. So, it should be it is specific in nature. So, and then 5, let us say we have a particular metal M, we need to protect that metal from corrosion, then we think of some inhibitors, let us say 2 inhibitors are added. So, that 2 inhibitors will act synergistically, that means both will work in tandem. So, synergistic in nature. So, in case of 2 or more inhibitors, so these are and of course, if we increase the temperature, or if we increase the, let us say the chlorine content is increased, or let us say pH is decreased. So, this cases inhibitor contain amount of inhibitor would also increase. So, these are the common characteristics of inhibitors, and let us see there are how many types of inhibitors are there. Types of inhibitor, there are mainly 4 types. One is passivator or anodic inhibitor, and there could be cathodic inhibitor, and now in that cathodic inhibitor, and there could be another variety which can be either cathodic or anodic, that is called barrier type inhibitor, which forms actually a barrier on the surface of the metal, and that barrier will not allow that corrosive species to react with the metal. So, there could be a barrier type inhibitor. So, then another, and but mainly the barrier type inhibitor either cathodic or anodic. Then organic inhibitor, and fourth is actually it is a vapor phase inhibitor. Now, if we come to the passivator or anodic inhibitor, so actually what they do, this if we consider passivator, let us say in terms of in case of if we consider in case of passive, they actually form a passive layer or helps in forming the passive layer. So, they affect the cathodic reaction. What they do, the cathodic reaction, they increase the electrode potential of the cathodic reaction or move it to the noble side, so that it goes to the critical it goes to the critical position, so that the passivation is possible. For example, in case of passive metal, if we know that this is the passive metal potential versus log I curve, this is basically the passive metal curve. Now, in that case, if a cathodic reaction is happening like this is my cathodic reaction. So, this is initially the corrosion rate. If we add those inhibitors, it keeps on moving the this cathodic reaction upward. So, finally, you can have like this, then this is the critical amount which actually crosses across this critical I critical, which is the current density, critical current density, and then once you have the situation like this, so this is the corrosion rate has moved to this plus. So, actually inhibitor moves this electrode equilibrium potential towards the positive side or noble side, and that means this is actually above critical, and this is critical, and these three are below critical. So, that means that the amount of passivator or passivator type inhibitor, that should be above critical value in order to maintain this passive current density. So, always the amount of the critical amount of this passivating inhibitor should be above critical value. Now, it can also, this is the major thing, this is the major activity of this passivator type inhibitor, and other things what it can do, actually it can stabilize passive layer, then also it can repassivate. For example, if the passive layer is damaged somehow, if we have those inhibitors, it can repassivate immediately. Then they can also assist to repair the film, so film repairing ability by forming insoluble products by chemical reaction. So, repairing ability, and of course, as I have told you that the critical amount, the amount should be above the critical amount that is needed to maintain the passive current density all the time, and the critical amount would depend on whether the temperature is increasing. If the temperature increases, critical amount would also increase, and also if you have the lowering in pH, critical amount would also increase. So, those are the cases, and then of course, let us say you have this particular metal surface. Okay, so, this is the metal surface on the, and for example, this is a tank where you would like to use this passivator, and these are basically the dead zone where the liquid is stagnant. So, care should be taken that the inhibitor presence is there in the dead zone. Also, one care should be taken that inhibitor, this passivating inhibitor should be throughout the surface. Otherwise, if for example, some portion, if the inhibitor percentage is less and if that is damaged, then the severe corrosion attack can happen in that damaged portion, because the inhibitor is less. At the same time, there would be favorable area factor, unfavorable area issue that would come into picture. So, that exposed part would act as anode and the surrounding unexposed part, which is a huge area, that would act as cathode. So, this is, and they can be of two types. One is direct passivator. They can be this passivator, one can be direct or it can be indirect. So, direct actually they are oxidizer, they are mainly oxidizers. What they do, they contains anions which oxidizes and then form insoluble which will be incorporated in the passive film. For example, we can have chromate or we can have nitrites. So, these are basically the oxidizer and they can form, they can combine with passive film and make the passive film very much adherent as well as impervious. So, this does not need oxygen to form the product, but to form to passivate the surface, but there are other oxidizer, for example, molybdenate, for example, this is molybdenate or tungstate. These are basically they need little bit of oxygen. They need little bit of oxygen to passivate, and the use are basically the reinforced cement in reinforced cement, calcium nitride is used. Or it can be also used in automobile antifreeze, where sodium molybdenate protects the iron as well as copper, brass, others. So, but these are the use, and indirect they actually what they do, they help to improve the adsorption, they help for passivating metal. So, they actually help to improve the adsorption of oxygen on the metal surface, or also they can also help in adsorption of those direct passivator oxidizing inhibitors. So, for example, one indirect passivator is NaOH. What it can do, it can it can take care of this OH minus ion, can take care of hydrogen ion. So, if hydrogen ion is taken care of, so the cathodic reaction is out, so the corrosion resistance would improve. Now, we can also think of some, so the barrier type inhibitors, actually barrier type which can be cathodic or anodic. So, one example is, let us say if we add zinc plus ion, which in order to neutral in the neutral environment, neutral solution which can protect iron corrosion. Iron corrosion would reduce due to the presence of zinc plus ion. So, the corrosion product which is OH minus, it can react with Zn plus. So, this forms a film on the iron surface or the cathodic regions, and that can prevent corrosion. So, this is one example, and there could be different types of barrier forming inhibitors. One is organic adsorption inhibitors. So, they form organic, there could be a possibility of organic adsorption inhibitors, and in this case the examples are, for example, sulfides or sulfides, organic sulfides, or mercaptans. So, those are some organic sulfides. What they do? They form a oily layer on the surface, and once we have the oily layer, this can prevent adsorption of hydrogen on the metal surface, or it can prevent the solvation of metal ion. So, if we prevent any of the steps which are needed for corrosion, we can prevent the corrosion. So, they actually form a oily layer on the metal surface, and sometimes they can also form stable surface complexes, which can also prevent surface adherence of this adsorption of hydrogen ion, or even it can prevent the solvation of metal ion. So, this is organic type inhibitors, or it can be inorganic type inhibitors. Inorganic inorganic inhibitors, which are basically a barrier type, and here we have the example of bicarbonates, or we can also have biphosphate. So, inorganic inhibitors which are barrier forming, those inhibitors are added which can react and form some insoluble product on the metal surface. For example, if we have bicarbonate, iron bicarbonate can form and which can protect the metal surface in case of alkaline medium, or we can have phosphate which can also react with iron, which can form iron phosphate, and that iron phosphate can form a insoluble protective layer and then prevent corrosion. So, then we can also have poison. The poison is a special type of cathodic inhibitor. For example, what they do, they actually poison the hydrogen reaction, cathodic reaction, poison the cathodic reaction. For example, in case of acid medium, we have this reaction, which is then this hydrogen would get adsorbed, and then two adsorbed hydrogen will react and it will form hydrogen gas. But somehow this poison are added, which are nothing but phosphorus, arsenic, antimony. Those are the poisons which are added, which actually prevents this combination reaction. If the combination reaction is prevented, the reaction is incomplete. So, the cathodic reaction is not happening. So, then if the cathodic reaction is not happening, so the corrosion rate of course would be very low, or so corrosion resistance would also increase. These are actually poison which is basically taking care of this hydrogen combination reaction. There could be poisons to prevent oxygen reduction. For example, this reaction oxygen plus H2O plus 4E, it goes to 4OH minus. So, this reaction, for example, we add arsenic or antimony in brass, which prevents in the amount around 0.1% is added, which actually prevents dezinkification in the brass. The mechanism is the corrosion, initially the copper as well as zinc goes out, both the ions go out and then copper redeposits back, and now what happens, there would be this one would react with arsenic, and react with arsenic, it can form arsenic OH4. So, this phase would deposit on active cathodic sites, and the active cathodic sites, because the copper is redepositing back. So, now the copper surface, this phase would deposit, and that further copper deposition will not be allowed. So, that way it prevents the dezinkification. This is the nature of the poison, which actually poisons that particular reaction. Now, we can also have a vapor phase inhibitor. Those are used in case of electronic products, for when this is for used for storage purpose or for shipment purpose. Those are basically, for example, one is dicyclohexylamine vapor phase inhibitors. So, here what happens, it actually forms one example is DCHN, which is nothing but the dicyclolamine. So, these vapor, they have a very low vapor pressure. For example, for this the vapor pressure is 3.3 into 10 to the minus 7 atmosphere at 25 degrees Celsius. So, they vaporize and form a thin layer on the metal surface and prevent corrosion. Now, let us see what are basically the mechanism by which the inhibitor works from mixed potential concept. Backing mixed potential theory on the inhibition effect. For example, if we have this log I versus E, for example, these are my two reactions. This is my anodic reaction, anodic polarization, this is cathodic polarization, and this is the corrosion rate. Now, if we add anodic passivator, anodic inhibitor, they can react in two ways. One is they can either shift this, which is basically exchange current density of this cathodic for anodic inhibitor, they can change this exchange current density of the anodic process and decreases its value without changing the polarization or over voltage. So, if this point is shifted to this, which is basically getting lowered due to the presence of anodic inhibitor, if we have again, if we see if this again mixed potential theory is seen. So, actually this has moved to this way and the corrosion rate has also gone down. This is my initial corrosion rate, let us say C I, and this is C anodic, C A means corrosion rate with the action of anodic inhibitor. And now, if we there could be another possibility. So, it changes the exchange current density or decreases the exchange current density, at the same time it increases the degree of over voltage, or if we increase the degree of over voltage. So, that means in over voltage is also increased, the polarization is increased as well as the exchange current density is decreased. So, this combination of these two process, the corrosion rate is further decreased. So, this is the effect of anodic passivator anodic inhibitor. Now, if we see the cathodic inhibitor, same way it can work. The exchange current density for the cathodic process can go down. So, it can go like this, my corrosion rate would be here. Now, or both the things can happen, this corrosion rate, the exchange current density would go down, at the same time the polarization would also increase. So, like this. So, this is my process, this is my new corrosion rate. So, corrosion rate is decreasing like this. Now, if we combine both the process, that means anodic and cathodic cathodic inhibitors both are present. So, the new corrosion rate would be this one. So, due to this anodic inhibitor, this has moved to this, and due to the cathodic inhibitor, this has moved to this. So, this is my new corrosion rate, which is basically the synergistic action of both anodic and cathodic inhibitors. Let us discuss protective coating. So, protective coating, the purpose of coating is mainly to improve the corrosion resistance of the metal surface or the wear resistance, and there are other effects. For example, if we have coating, then we can improve the fatigue property of a metal. So, but in the current situation, let us talk mainly on the with respect to corrosion, improvement in corrosion resistance. So, the basic importance of coating with respect to corrosion improvement, corrosion resistance, the basic importance. One is it should improve the corrosion resistance. And what it can do, it basically acts as a barrier, for those cathodic or anodic reactions, or they themselves interact or function in the cathodic or anodic reactions, and that way they can prevent corrosion. So, actually this barrier type of coating, for example, paints, simple paints, they generally do not interact with the species. Actually, they prevent those corrosive species to come in close contact with the metal surface. So, that reaction, anodic or cathodic reaction, would not happen on the metal surface. So, the barrier type third is it can be cathodic protection. One famous, one very important example is anodic sacrificial anode, which is galvanized iron zinc coating. Actually, they dissolves, and on the way they protect the metal surface iron. So, the cathodic protection it can do cathodic type coating, or we call it sacrificial coating. Sacrificial coating. Then we can also have inhibiting type of coating. So, they will have action just like inhibitor. Then many cases they simply provide electrical resistance, which is mainly the electrical resistance increases. If the electrical resistance increases, then for those anodic and cathodic reaction, that reaction process would go very slow. So, these are the main importance of protective coating, and then mainly and then key characteristics are of the coating. Key characteristics of coating, they should provide good corrosion resistance or excellent corrosion resistance. Then second is they should adhere to the surface perfectly. So, adherence to the surface, then we can have on the metal surface, if the coating is done, it should be continuous, and in case if it is discontinuous, for example, in case of paint, if we paint the surface, let us say this surface is painted and this is the paint zone, this is the paint zone. Now, by chance if the paint zone on the paint zone there is one small discontinuity, and that discontinuity is called holiday, which is basically also called holiday defect in case of painted surface, and this part the corrosion would be huge, and then the metal object can fail if it is under tension. So, the coating should be continuous and completely covering the surface. And then fourth is basically the life of coating should be excellent, or the good long life or long life of the coating. It should not decompose with time quickly. Then the another thing is when we have a coating, the surface finish, for example, on a metal surface this is the metal surface, on that metal surface we are planning to have coating, and that time the surface preparation of the metal surface on top of which the coating is to be done, that is very important. For example, if a good coating is done on a badly prepared surface, that can give you a very deadly effect, corrosion rate would be very high. At the same time, if the bad coating is done or for example, a coating which is not that resistant to the environment, if it is done on a very well prepared surface, then it can function well. So, that means the surface finish or preparation is another important issue. So, these are the key characteristics. Now, we can have different kinds of coatings. It can be either metallic, broadly it can be either metallic or non-metallic. So, the varieties of coatings, it can be broadly classified into two varieties. One is metallic, another one is non-metallic. So, the metallic, generally the characteristics of metallic coating, they are durable, more durable, they are aesthetics is good, decorative, then they can give a very good shielding against corrosion, good shielding, good shielding. So, these are the basic characteristics or importance of metallic coating, and it can be, and for the metallic coating to be done, the surface preparation, this key factor or the we can say that characteristics or factors. So, key factors, one is surface finish of the metal surface on which the coating is to be done. That surface finish is to be very good. For example, it should not have any coat, it should not have any rust on the surface, it should not have oily or greasy surface, so that those things will negatively interact with the metallic coating. So, the metallic coating can be the strength of the metallic coating would be less. So, that is what the surface should be very clean, and that cleaning is to be done properly by either solvent emulsion or pickling or acid leaching. So, those are the acid treatment, those are the ways to prepare the surface. And the metallic coating, it can be divided into two section. One is cathodic, another is anodic. So, that means one particular example for anodic coating, we have seen many a times the example, that is galvanizing. Galvanizing, that means zinc coating on iron surface, and cathodic, one particular example we have seen while we discussed about the effect of different effect of areas, the unfavorable area on the corrosion of the base metal. So, that time we have discussed about tin coating as well as tin coating, that means SN coating and zinc coating on metal iron surface. So, that time we have seen that the cathodic coating would be very good. This is basically one example of cathodic coating. Cathodic coating would be very good if there is no crack or discontinuity in the coat, but if there is any crack or discontinuity, that would be a very deadly effect, because that the entire surface would act as cathodic area, and the small section of the iron which is exposed to the solution or the environment atmosphere, that would act as anode, and so unfavorable area issue would come, and the corrosion rate of that exposed part would be very, very high. So, another example of cathodic coating is actually gold on steel. So, these are various examples of cathodic and anodic coating. Now, coming to the non-metallic coating, so non-metallic coating, one variety is there are inorganic or organic coating. Organic coatings are generally paints, enamels or varnish, and inorganic coating, there are various ways we can have inorganic coating. One is vitreous, enamel. So, these are basically the hard glassy surface, glassy, vitreous means glassy, hard glassy layer, hard glassy layer on the metal surface, and due to that protection is done. Then we can have Portland cement coating. Portland cement, generally they are very thick, and in that Portland cement generally the pH is maintained, pH is in the range of pH is more than 7, that means it goes to alkaline, that the surface becomes alkaline in nature. So, actually the pH is raised. Portland cement is one important inorganic coating on steel object. Then we can also have chemical conversion coating. Chemical conversion coating, actually what it does, that coating material intentionally the metal surface, the way it is done, actually the metal is intentionally reacted with the environment, and during that reaction of impervious layer is formed, and that layer would be resistant to corrosion. For example, one example is anodizing of aluminum. What it does, the aluminum is intentionally taken to nobler side, the potential of aluminum. So, that means it is intentionally taken to the nobler side. So, when it is taken to the nobler potential, the aluminum oxide forms, and that aluminum oxide, due to this anodizing effect which is happening a very high potential beyond that the potential where oxygen evolution occurs. So, the anodizing aluminum is one important chemical conversion technique by which aluminum oxide layer is forming on the surface, and it would give very good corrosion resistance. Then we can also have phosphate coating. Phosphate coating here in case of iron, if we dip it in dilute phosphoric acid, then the iron phosphate is forming, iron phosphate would form on the metal surface, and that gives the protection. Okay. So, then we can also have chromate coating. So, again here what it does, what is done, actually the either the metal object is which is could be aluminum, could be zinc, could be cadmium. So, there this metal object is dipped in chromate solution or the chromic acid solution, and the chromate layer is forming, layer would form on the metal surface and it would give protection. So, the chromate coating. Then also we can have oxide coating. Oxide coating, here aluminum, for example, in this case aluminum is oxidized in the presence of chromate or dichromate to obtain a thick strong oxide surface on the metal surface. So, these are few techniques. Another technique could be nitriding or carburizing. So, these are basically the gaseous technique, the metal surface is heated in the metal in the presence of gas, nitrogen gas, and then carbide or nitrides are forming on the metal surface, and it would give very good corrosion resistance. Then there could be rust converter. For example, E and then F rust converter. So, for that some chemicals, for example, tannin is added, and that on the metal surface, for example, steel, the rust is forming, and then if we have tannin, the tannin seeps through the oxide layer and it forms a non-porous stable passive surface film, non-porous stable rust. So, that way we can protect corrosion. And then there could be organic coatings. In case of non-metallic coating, we can also have organic coating. Non-metallic section we can have then 4 organic coating. Generally they are plastics or enamels, or it could be resin, or it could be a lacquer. So, these are the organic coating which is actually physically deposited on the metal surface, and then we can actually those acts as a barrier which will not allow the corrosive species to come in contact with the metal surface. That way they prevent plastics, they prevent corrosion, or they increase the corrosion resistance. And as we have mentioned, in case of organic coating, there could be a possibility of holiday defect, and that is what it is always preferred to have a multi coat rather than a single coat. The single coat holiday defect would be more, or the metal surface or the coated surface or the plastic or the organic coating would have many more defects. So, that time that can be very bad for the from the corrosion resistance point of view. So, this multi coat is essential, and there could be, and this one criteria is this coating should be resistance, high electrical resistance they should have. If they have a very high resistance, electrical resistance, then they can prevent the cathodic or anodic reactions, or the anodic or cathodic reaction rate would be low. So, those are the common characteristics of organic coating. And let me also come to the fact that what could be the common failures associated with organic coating. So, we see that high resistance of those organic coating is one of the important issue. Then sometimes with this organic coating, generally sometimes inhibitors are added. Let us say sometimes we add zinc in the paint. So, the zinc would act as, this basically would be sacrificial, would have sacrificial action. Sacrificial action with respect to iron. So, zinc is added, and many times sometime red lead or zinc chromate is added, which will be acting as inhibitor. Now, let us see what are the common problems that are experienced with respect to the organic coating. So, one problem could be the problems blistering. So, the organic coated surface, due to the action of oxygen and water or gaseous, that there could be a blister formation on the metal surface. There could be early corrosion before the paint gets dried, or there could be problem of delamination during exposure of that coated surface to the corrosive media, or there could be filiform corrosion. Filiform corrosion is also another type of crevice corrosion, where you have let us say this is the metal surface and this is the paint. So, the paint basically, this is the paint. So, actually the paint is peeled off like this, and there could be a problem of they will form a sort of filament on the metal surface if this is the metal surface. So, there could be filament type of growth like this. So, again another one would come like this. So, this kind of filiform corrosion can happen on the metal surface, on the painted surface. So, these are the common problem with organic coating. Now, let us finally discuss what are the methods by which we can apply coating, metallic surface coating or different other coatings. So, the methods of application. Now, it can be mechanical way, it could be cladding, it could be mechanical painting, mechanical plating. Due to the mechanical action, there could be mechanical plating, there could be painting. So, then we have the physical method. These are basically mechanical method, where mechanical method where we add the mechanical action, mechanical force in order to have the coating. Then we can physical method. Physical method, in this case it could be a high temperature, method, or it could be low temperature method. In the high temperature method, it could be hot dipping, or for example, zinc coating is done by hot dipping. Then we can have welding, we can have spray fusing, or it could be laser. Then in the low temperature process, we can have cathode sputtering, or it could be metal spraying, Then finally, we have one more method, which is chemical methods. Chemical methods, in case of chemical methods, we have different varieties. So, the chemical methods in that it could be either high temperature again, or it could be low temperature methods. Some of the examples of high temperature methods are either chemical vapor deposition, or we can call it as CVD. We can also have autocatalytic electroless plating, or it could be chrominizing or aluminizing, and low temperature case we can have it could be electroplating, or it could be anodizing, or it could be phosphating, like that. Even brass painting, brass plating, or it could be brass plating, or it could be vacuum deposition. So, these are many techniques which are available in order to have coating on the metal surface. So, now we finish the discussion on the methods by which we can have protection against corrosion, or we can improve the corrosion resistance of a material. So, we have majorly 4 techniques. One is by changing the design, another one is by changing the environment or changing the metal or material selection, and then fourth one is electrochemical ways of protection, and then finally, we have the protection by coating.